right, friends. So, I'm going to go through and do these. And as I have a suggestion at the top, you should pause the video when you get to a new page and attempt to do the work that's on the page. If you've already done the problem, that is fine. Just keep on watching. But if you haven't, pause the video and then try to do the work and then see if you can figure out what's going on. And if I have any questions along, feel free to answer those. All right, so we have a stem of a question here. The rate at which people enter an amusement park on a given day is modeled by the function e for enter. So, this is a rate, and that's the rate in. So that's when they're coming in. The rate at which, that's a rate, they leave is L. So that's the rate out. So sometimes these questions have a rate in and a rate out. Sometimes they just have a rate in. It depends on what kind of question we are looking at. This one has a both rate in and rate out. Both E of t and L of t are in people per hour. These functions are valid 9 to 23. And at t equals 9, there are no people. So at t equals 9, no people. So 9, 0 is going to be a point I bet we're going to have to use at some time. Which makes sense. That means at the beginning, there are no people in the park. I'm assuming we're ignoring workers. And let's see. So, if I were to integrate E of t, that's going to be, we're going to integrate the rate. So that's in people per hour times hour. That's going to be people in. So number of people in over some time period if I put like an A and a B there. A to B. And then if I integrate A, B, L of t, that's going to be the number of people out over AB. Let's see. If I wanted to figure out the total number of people at the park, I'm going to have to combine those two expressions. If I take the number of people in and the number of people out, if I subtract, that'll be how many people are in the park at any given time. That makes me think, okay, wait, I might need to find a maximum number of people in the park at some point. So if I want to find the maximum number of people in the park, that's going to be, okay, let's process. So if I want to know number of people in the park, I don't know if we're going to be asked these questions, but if I process a little bit before I attempt the question, that might help. Number of people in the park, that'll be integral A to B enter minus integral A to B leave. I could do those as one integral if I wanted to, that would be fine. Now, if I want to know the max number of people, or the min, I would just take the derivative of the number of people and look at that. Well, if I take the derivative of the E of t, maybe not A to B, because that will just be a number, so that would be 0. If I take the derivative of E of t, maybe 9 to x and 9 to x, then that's just going to be E of t minus L of t. That's a fundamental theorem of calculus, the derivative portion of things. If I take the derivative of an integral, they kind of cancel each other out. And when I look at for maxes, I want to know when the derivative is equal to 0. Okay, I think I've processed some of the stuff I might have to look at. Let's see what we got. The rate at which, the rate in, rate out, people per hour, so that's still people per hour. Don't forget that information. Hours after midnight, there's still no people in the park at 9. How many people have entered the park at 5? T equals 17. Well, all I have to do is take the integral from 9 when we open the park to 17 of E of t dt. Now, this is a calculator question, so I'm going to go ahead and put that in my calculator. Now, depending on what kind of calculator you have, you may want to put this function into like a graphing piece of your calculator so that we can recall it later, or we can use it in our integral or derivative functions of our calculator, whichever we're going to use. Just depends. So we might want to put that, if we have like a TI calculator, maybe put that into Y1 or something like that. Might make life easier. Okay, I need to integrate this. I keep talking as I'm trying to calculate this. 9 to 17 and calculate. So I get 1560, yep, and x squared, yep, okay. So I get 6,004.270. So round to the nearest whole number. So approximately, I don't have to write this sentence, but I'm going to. Approximately 6,004 people have entered the park by 5 p.m. We added up all the people who were entering, and we figured out we got about 6,004 of them have entered the park. All right, let's see what we got next. Same stem, entering and leaving, rates, don't forget those are rates. E of t in, L of t out. We open at 9, there are no people in the park. Price of admission to the park is $15 until 5 p.m. After 5 p.m., the price of admission is $11. How many dollars are collected? Okay, there are a couple ways to process this. Let's do way number 1. Way number 1 is to take my answer to A, which was 6,004, and multiply by 15. And that's going to be 6,004 times 15. You might be faster than me, and that's totally fine. 90,060. And then I could write the integral. Let's see, I need to go from 17 until the park closes at 23. So 23 e of t dt. So if I put that into y1, I can reuse that information. And I need to go 17 to 23. And I get 1271.283. I'm going to call that 1271 people. So I'm going to take my 1271 and multiply by 11, right? So multiply that by 11, and then 1271 times 11, and that's 13,981. And I'm going to add that to 90,060, and I'm going to get total amount collected is $104,041. And let's see. That is one way to do it. Another way you could do it is just take the integrals. I'll do it a second way. Take the integrals, so 9 to 17 e of t dt, and multiply by 15, and then 17 to 23 e of t dt, and multiply by 11. If I do that, I will get, let's see, that's times negative 11, because I'm going backwards, 1398411, and then I'm going to need to multiply by 15, and I need to go 9 to 17, and I get 90,064.05. So if I add those together, it's going to be roughly the same, but slightly different. And the 0.05 and the 0.11 definitely don't really make sense in the context of this question. I get 104,048 and 16 cents, but they tell me not to pay attention to those. So there's a $7 difference there. Now, to me, the way above makes way more sense than the way below. Because the way above says, okay, how many people have entered, round that, and then figure out how much money that is. The way below says don't round, so we have like partial people paying for tickets, which doesn't really make sense. But I think they'll accept either way. Now, if this were the AP test, I would not submit my answer like this. In fact, what I would do is I would say don't pay attention to this because I don't want you to. The answer above is what I want. But I wanted to show you that you could think of it kind of two different ways. What do we have here? Same stem, as always. H of t, 9 to t. The value of h of 17 is to the nearest whole number is 3,725. Okay. Explain the meeting. So we talked about this already at the beginning. H of t is the number. I don't need to write that down. H of 6 or 17, whatever we're talking about. 17, there we go. I'll get there eventually. Is the number of people in the park at t equals 17. Number of people in the park at t equals 17. So, I mean, we could call that, that's hours after midnight, so we could call that 5 in the afternoon or whatever. But we don't need to. So, number of people in the park at t equals 17. So, then we need to figure out, okay, what is h prime of 17? H prime of 17 is going to equal, that's just e of 17 minus L of 17. And when I put that in my calculator, e of 17 minus L of 17. All right, so if you had it in like y1, you could do it that way. Go for it. I need L of 17. So let me put that in my calculator. And again, you could put that into, you know, y1, y2 in this case, or whatever you want. It is up to you. And let me continue talking. So I'm finding the difference between entering and leaving. So the difference between, not entering, leaving, careful, the rate at which we enter and the rate at which we leave. So if I find the difference in those, that should tell me the rate at which people are either entering or leaving the park overall. So I have E of 17 minus L of 17, and I get negative 380.281. And that is in, so H prime, that is in P, so that is the same units as this rate up here, because that's E and L, and people per hour. So in the context of this question, there are about 380 people leaving the park overall at t equals 17. So there are 380 more people leaving than entering, is basically what's going on there. Last part, same stem. At what time does the model predict the number of the people in the park is a maximum? Okay, so we just talked about this. So we have a maximum when h prime of t equals 0, and h prime goes from positive to negative. So h prime of t equals E of t minus L of t. So you can either set that equal to 0, like you have to set that equal to 0, but on your calculator you can either set it equal to 0, or you can say, okay, when do these two things equal each other? So when do they intersect? And you might, I'm gonna play with my window a little bit, so I want to go 0, because that might be a hard part for you, 0 to 24, and then my y value, I'm not quite big enough, so I'm going up to like a little over 1,000 probably, and I can figure out that they hit each other at t equals 15.795. So we can claim h of 15.795 will be a maximum because h prime of t equals 0 and h prime of t goes positive to negative. And I know that because my entering is bigger than my leaving until 15.795, and then my leaving is bigger. And once my leaving is bigger, that's when we're going to decrease in the number of people in the park, so we have max. All right, so let's recap the whole question. So we're given a rate. This is the rate in, I told you this at the beginning, and the rate out. The units on that rate are in people per hour, and we're measured 2 hours after midnight. We only care about 9 to 23 because that's when the park is open. In the beginning, there are no people in the park. How many people have entered the park by 5 p.m.? So that's simply saying, okay, I know the rate at which they enter, so integrate my enter. So I integrated that. Part B is just taking that integration that we just talked about and multiplying by 15 and then adding the rest of the piece. So we have to integrate for the rest of it. So that's still related to my integral of e of t. But it's making sure we understand the context of the question. Can we attach some money to this situation? And then for part C, h of t is the integral from 9 to t. So that's how many people are in the park because we're adding up how many have entered. We're subtracting how many have left. And now we want to, they tell us that h of 17 is 3,725. In the context of the question, that's how many people are in the park at t equals 17. The derivative is just, get rid of this part. So h prime of x is e of x minus L of x, or e of t minus L of t. I guess I should put t's there, that might make more sense. And so that's the rate at which people are either entering or leaving overall. And we got a negative number there, so more people are leaving than coming in. And then for part D, at what time does the model predict the number of people in the park is a maximum? So we have a maximum, you should know this, you have a maximum when the derivative goes from positive to negative, or the overall function goes from increasing to decreasing. That occurs at that like 15.795 or whatever I found, because that's where the entering and leaving rates, E and L, are the same, and that's when the derivative h prime goes from positive to negative, or the overall function goes from increasing to decreasing. Let's see how we did. 6,004 people entered the park by 5 p.m. We got that. Total amount collected was 104,041. So we did this part. They gave us that option 2, which I talked about. H prime, there were 3,725 people at the park at t equals 17. The number of the people in the park was decreasing at a rate of 380 people per hour. I don't remember if I put units, but I hope I did. If I didn't, I'm sorry. And then h prime equals 0 at t equals 15.795. Again, so that part D was where do we have a maximum, right? And we need more justification now. This is not enough justification. So you need to have just a sentence about how h prime is going from positive to negative, or h is going from increasing to decreasing at that 15.795.